For my report, catalytic properties of multiple carbon nanotubes modified with cerium oxide in reactions of n-butanol conversion to ketones. One of the most important problems of modern science and practice is the treatment and recycling of organic, industrial, domestic and agricultural waste. Organic waste from livestock, crop production, processes, companies, products of human activity that are accumulated as technogenesis byproducts account for significant amounts and don't fit into the natural biological cycle. It leads to pollution of air, water, land, agricultural products, and finally negatively affect on human health. Today, the current issue of chemical industry is control of waste or excess materials which contain organic compounds. The concept lays in utilization of harmful and renewable raw materials of renewable raw materials. For example, industrial waste of fats can provide raw materials for production of amphiphilic compounds. For this purpose, the reaction of primary alcohol conversion into ketones under influence of oxide catalyst should be made like this. The method allows the transformation of waste or materials containing organic compounds. Examples of such transformations are mixes of monocarboxylic acids, isobutyraldehydes, alcohols, or esters fractions. Based on the importance of this problem, we investigated the catalytic effect of multi-wall carbon nanotubes modified with cerium nanoparticles in such reactions. It is a method of control of organic waste containing primary alcohols, aldehydes, and ester. Cerium compound, using as a modifier cerium compounds, is conditioned by their chemical and physical properties. In particular, cerium oxide is a catalytically active carrier, and due to their high surface activity, is capable of strong interaction carried phase. Catalysts based on cerium accelerate practically important reaction between hydrogen and carbon monoxide, reactions of dehydrogenation of alcohols, and processing cracking, petroleum cracking processes. Cerium-containing catalysts characterized exceptional selectivity and thermal stability, and due to their synergy effect, they can be compared with platinum ones. An important area of cerium consumption is control of the composition of car exhaust fumes. Addition of cerium into catalysts significantly improves and stabilization of their work, prevents their destruction under heating, and increases its activity, providing the high degree of toxic substances decomposition. Why do we use carbon nanotubes? Because they can be carriers or detectors of their catalytic properties. These opportunities are caused by high values of specific surface area of carbon nanotubes, features of their structure, thermal stability, and resistance to aggressive environments. Carbon nanotubes' ability to detect of catalytic properties makes them a very important subject and a member of the following transformation and utilization of organic waste, creation of organic catalysts for fuel cells, creating selective biosens or bioseparation processes, biocatalysis, directional transport of drugs, etc. Catalysts based on carbon nanotubes are more active than those which include other carbon materials. For example, carbon nanotubes compared with graphite and soot are showing highest activity and selectivity and give the highest yield of product of reaction of dehydrogenation. And also carbon nanotubes are resistant to oxygen catalysis, while the soot completely disappears after 7 hours oxidation. And it is known that catalysts based on carbon nanotubes are effective in different reactions, for example, decomposition, oxidation, dehydrogenation, hydroxylation, etc. So, the catalytic materials with mass modifier 5.2% has observed by sedimentation of oxides on carbon nanotube surface from solution by a reaction. We used multiple carbon nanotubes, which were synthesized by CVD method, employing iron-containing catalyst. The carbon nanotubes have an external diameter of 10 to 40 nanometers, specific surface area of 200 to 500 square meter per gram, and purity of about 99%. Analysis of spectral characteristics showed the formation modifier particles on the surface of carbon nanotubes. Their size is 6 to 10 nanometers. Elemental analysis showed of such system are following. Was found carbon, this is signal from carbon nanotubes. Iron, this is catalyst remains in the cavities or pores of carbon nanotubes. Serum, this is modifier, and sodium, and this is remains of sodium nitrite after preparation of composite. Samples investigations by Raman spectroscopy showed formation cubic structure of cerium oxide on graphene surface of carbon nanotubes as evidence peak at 452 inverse centimeters. The differences is peak position and their intensities are not observed. Therefore, the graphitization degree of carbon nanotubes is constant before and after modification. XPS analysis has confirmed the formation modifier particles on the walls of carbon nanotubes as cerium 3+. This is indicated by manifestation of spectrum of cerium 3D electrons. Similarity of XPS spectra in maxima positions indicates identical distribution of functional groups on carbon nanotube surface. Analysis of oxygen 1s spectra confirms the existence of single bond with oxygen and single double bond with oxygen on carbon nanotube surface, and also the presence of water. Catalytic testing has performed with a lot of composite depending on the temperatures changes. Volume of catalyst in the reactor was 4 cubic centimeters. Measurements under constant temperature and different value of power intensity didn't show depends of exit of reaction products and selectivity of catalysts, that indicating of significant activity of the system. The studied catalyst, in contrast with other oxide catalysts, were unusual in mechanism because reaction takes place with splitting of hydrogen and the formation of butyraldehyde. Then the biomolecular condensation of ether and transformation to form symmetrical ketone happens. The mechanism of reaction probably is following during the interaction with oxygen several types of functional groups which forming on surface of carbon nanotubes. Among them are electrophile and nucleophile, which contribute to oxidative dehydrogenation and next conversion of aldehydes into ketones or esters. Among the product of reaction, we obtained butyraldehyde, heptanone, butylbutyrate, butane, and other products. The highest yield of butylbutyrate and heptanone butylaldehyde, and heptanone at temperatures range of 440 to 480 Celsius degree, and the highest selectivity of catalyst to these components is manifested. Yield of other products is similar, is slight in the whole temperatures range and practically unchanged, so we can ignore them. Thus, the activity of catalyst is determined by size effect of carrier and modifier particles and by distribution of functional groups on the catalyst surface. For establishment of working mechanism of primary alcohol conversion and proof of synergy effect, we plan same test with other systems. It will be multi-wall carbon nanotubes modified with silver compounds and silver and serum compounds together. That's all. Thank you for your attention.
Time for questions.
What does it mean, size effect of modified groups?
Shows.
What does it mean, size effect of modified groups? In
This is
conclusion.
Size.
nanometers, nanosize. I mean nanosize.
But what does
Effect.
it mean? Please explain.
The formation of modifier particles is necessary. The formation of modifier particles smaller than 10 nanometers is necessary for achievement of activity of the system, because we must obtain a system with nanosize particles and nanosize carrier.
Your question?
My question is about these carbon nanotubes. You grown them by CVD technique. Which type of precursors do you use?
We used hydrocarbons, yes?
No, for growing of nanotubes you need some precursors.
We using for synthesis we using three-component catalyst and three-component catalyst, iron-containing catalyst, and hydrocarbons. For example, propylene or
CVD они не растят,
But you have to put some precursor of, for example, platinum, small particle.
No, we don't have precursor. This is a chemical vapor deposition method.
Открытая система идет.
Okay. Have some other? Another question? No? Thank you again.